Hello dear learners, welcome to a new video of a new and interesting science lesson. This lesson is about force, energy and simple machines. Now just relate everything that you learn in this lesson to your everyday experiences and you will find it very interesting, easy to understand and remember. So let's get started. In this video, we will be learning about the definition of force and the effects of force by which we can identify force. You'll also be learning about balanced and unbalanced forces and the types of forces, namely the contact and non-contact forces and their different subtypes. Now when you think about it, as you're sitting on your chair or in your position wherever you are, there are certain forces acting upon you. Could you name them? Yes, there is the force of gravity that is pulling you down. Now, whenever you apply a force on a substance or an object, it applies an opposite force upon you. So, the ground is always there pushing you up, exerting a force in an opposite direction. The air is squeezing you from every direction as we are covered by a blanket of air called the atmosphere. And our body is pushing back at the air and preventing our body from just collapsing because of the air pressing down upon us. This is because our body has several air pockets or air cavities like our ears, the stomach, our lungs, which are also filled with air and push back against the air that is trying to compress us. So these are some different forces which act upon us at any given time. Now think about it. What if the force of gravity was taken away? What would happen? Well, if the force of gravity was taken away, you would definitely float in the air. When forces are balanced, they cancel out each other and we don't notice them. But when forces are unbalanced, then things begin to happen. In this image, you can see that both teams are tugging at the rope with equal force in opposite directions. And because of that, the rope does not move and neither team wins. When we look at the second scene, the team on the left is tugging with greater force, causing the team on the right to lose their balance and move towards the left. How can we measure force? Force is measured in units called as Newton, which is represented by N. So we could say that in the first case, there is an equal force of 300 Newton, which is exerted by both the teams, but in opposite directions. And therefore, the forces simply cancel out each other. In the second case, the team on the left is definitely exerting a greater force. And by how much is this force greater? 400 minus 300, 100 newtons. And therefore, we could say that the team on the right moves towards the left with a force of 100 Newton. Now let's solve some balancing problems. We could say that the green car moves towards the left with a force of 100 Newton. The rocket is propelled or moves up with a force of 2000 Newton. The orange blob is pulling with a force of 500 Newton and the green blob is pulling with a force of 1000 Newton. Therefore, the force towards the right is bigger than the force towards the left and the resultant force is towards the right because the greater force is towards the right. The orange blob is pulling with a force of 1000 Newton the green blob is pulling with a force of 1000 Newton. Therefore, the forces are the same and cancel out each other. There is a resultant force of 1000 minus 1000, 0. And therefore, neither would move, but they are keeping on exerting the force in equal and opposite directions. The parachute jumper falls to the ground because of a force of 600 Newton. But the parachute helps to slow his fall by creating a 400 Newton of air resistance. Therefore, the resultant force is 600 minus 400 Newton, and the resultant force would be downwards because the downward force is greater, and it would be of 200 Newton. Now let's take a look at the effects of force, or what are the consequences of force. What is force? Force is a push or pull on an object, and a force comes into play when two objects interact with each other. Therefore, we can say that the effects of force are as follows. 1. Force can make a body at rest move into a state of motion, or force can make a body in a state of motion to come to rest. Force can also change the speed of a moving body by increasing it or decreasing it. Force can also change the direction of a moving body, just the way you would kick a football to change its direction. Force can be applied to change the shape of objects, and force can also be used to change the size of certain objects. So these are the 4 different effects of force. Now let's determine whether the force applied in all of these cases is a push or a pull. As you can see, the boy is pushing the box, the child is pulling himself up the bar, the boy is pulling himself up the rope, the child is pushing the wagon, the nozzle of the spray can has to be pushed, the girl is pulling the trolley bag. In the examples that we've just saw, it was always required that the person is in contact with another object to apply a force on it. But do all kinds of force require contact between surfaces? Can you think of any force that does not require direct contact between two objects? I'm sure many of you must have thought of gravitational force. So what are non-contact forces? Non-contact forces are forces experienced by bodies even if they are not in physical contact with each other, like gravitational force. The Earth exerts its gravitational force on any object inside its atmosphere, within the atmosphere. The object does not have to be in contact with its surface. Another non-contact force we are going to learn about is electrostatic force, which is a force exerted by a charged body. Magnetic force is also a non-contact force. Coming to contact forces are forces experienced by bodies only when they are in physical contact with each other. Just like muscular force. If you want to push or pull an object, you use your muscles, but you have to come into contact with that object. And therefore, muscular force is a contact force. And so is frictional force, about which we will be learning more. The first non-contact force we are going to learn about is gravitational force. So what is gravitational force? So gravitational force is a force of attraction between any two objects that have mass. Yes. So gravitational force is not a force that is exclusively found on the planet Earth, but is a force that exists in any object that has mass. But the extent of gravitational force of an object depends upon two factors: the mass of the objects and the distance between the objects. Now think, why do you suppose the earth exerts a force on you that you can feel, but you can't feel the force the desk is exerting on you or and objects around you are exerting on you? Yes, this is because the mass of the desk or any other object around you would be negligible when we compare it to the mass of the earth. So, gravitation is a force of attraction acting between any two bodies of the universe. Gravity is the Earth's gravitational pull on a body lying on or near the surface of the Earth. Now look at these two scenarios and let's find out when the gravitational force between the objects will be greater. Gravitational force depends on mass. Therefore, the gravitational force would be greater in this case where the mass of the objects are greater. That is because if mass increases, the force of gravity increases. Gravitational force also depends on distance. Therefore, the gravitational force would be lesser in the second case where the objects are farther apart from each other, and it would be greater in the first case where the objects are closer to each other. This is because if distance increases, the force of gravity decreases. Now, can you explain why things weigh lesser on the moon? An astronaut whose mass is 120 kg would have the same mass on the moon, but the weight of the astronaut would be much lesser on the moon because the gravitational pull of the moon is much lesser than that of the earth. This is because the earth is 81 times the mass of the moon, and therefore its gravitational pull is much more stronger, and therefore we weigh much more on the earth as compared to the moon. Now let's learn about the non-contact force, that is electrostatic force. Electrostatic force is a force that is generated when we rub an object like plastic or a glass rod against a dry surface like a piece of silk or wool, your dry hair or a sweater. What this does is it results in an accumulation or a collection of a certain type of charge on that object, causing it to attract or repel other objects which may be charged or uncharged. Electrostatic means a charge which does not move, because the word static means which is stationary or which does not move. In the world of static electricity or electrostatic force, oppositely charged objects attract each other. That is, if an object is negatively charged and if the other one is positively charged, the objects would attract each other. Just the way the comb attracts the bits of paper, because the comb has just been rubbed onto a surface and therefore it is charged. Whereas objects with like charges, that is the same charge, would repel each other or move away from each other. Now let's learn about the non-contact force, that is the magnetic force. A magnet is a substance with a north pole and a south pole. As a magnet is a substance which attracts a force called as a magnetic force upon other substances which are magnetic. And what are these other substances which are magnetic? We have learned that iron, cobalt, steel and nickel are all naturally magnetic substances. Every magnet has a north pole and a south pole. Now, does the magnetic force push or pull objects towards magnet? Well, I'm sure you have played with magnets and you have noticed that sometimes magnets, when placed in a certain way, move away from each other or repel each other, and sometimes when magnet placed in a certain way, attract each other. This is because when magnets are placed in such a way that they are like poles or the same poles face each other, they repel or move away from each other. And when magnets are placed in such a way that their unlike poles or opposite poles are facing each other, they attract each other. Now let's learn about certain contact forces. Look at the picture. Is it easier to ski on grass or on snow? One of them produces more of a specific force, and what is this force? Well, it is definitely easier to ski on snow rather than on grass. And this is because grass produces more of a force called as frictional force. Frictional force is an opposing force which comes into play only when objects are in motion. That is, when objects are moving. So frictional force occurs whenever two surfaces rub against each other. It is a force that always opposes motion or acts in a direction opposite to that of the direction of motion. So what causes the frictional force? No matter how smooth the edges of objects may appear, the edges are actually rugged and uneven as seen in this figure, and therefore they lock against each other, causing the motion to slow down and giving a grip. We use friction to slow things down. For example, friction between our shoes and the floor stops us from slipping. Friction between tires and the road stops cars from skidding. Friction between the brakes and wheel helps bikes and cars to slow down, and we can think of numerous more examples. Friction also appears in two other forms. Air resistance is a type of friction which slows the fall of a parachute or a piece of paper in air. The bigger the surface area, the greater the amount of air resistance. Therefore, we could say that gravity or the gravitational pull of the earth pulls down any object down with the same amount of force, but it is air resistance that actually slows down certain objects like feathers or balloons because of the greater surface area. Water resistance is also another type of friction which slows objects moving through water. Friction can also be problematic. If an object is not moving, then it will have zero friction because friction acts upon objects only when they are in motion. Whenever friction occurs, you always feel the effects of friction, which are namely heating and wearing. This is why your palms get heated up when you rub them against each other, and this is why machinery gets heated up when you run them. Have you noticed how the tires of your cars or bikes become smooth after a long period of use? This is because the friction wears the rubber because of continuous use and smoothens it out. The effects of friction can be reduced by using a lubricant so two materials are not actually in contact with each other. In a similar way, oil is used in car engines and on your bicycle chains and in machinery to reduce friction so that wear and tear can be reduced. In nature, animals are often seen to be streamlined to reduce the frictional effects of air resistance. Which of these cars seem to be more streamlined? As you can see, air would flow right over the first car, whereas it would resist the movement of the second car even more. Therefore, we could say that the first car is more streamlined than the second one. In a similar way, ships and boats also have streamlined hulls to reduce the drag effects or the slowing effects of water due to water resistance. Let's learn about another contact force which we use in our daily lives. That is the muscular force by animals. So animals as well as humans use muscular force for our daily activities. Muscular force is the power applied utilizing portions of our body like our arms or legs which are movable. Muscular force is required whenever we move our body or for our daily tasks like strolling, lifting, moving around a house, crossing a leg. No matter how small or big the activity may be, we require muscular force. And we have learned that it is muscle contraction and relaxation which generates this force. Now let's learn about the third contact force, that is elastic force. Elasticity is the ability of an object or material to resume its normal shape after being stretched or compressed. Therefore, an object which has elastic force or the property of elasticity would come back to its resting state position whether you stretch it or whether you compress it. The fourth contact force we are going to learn about is buoyant force or upthrust. Buoyant force is the upward force exerted on an object by the fluid surrounding it. Experienced how you feel lighter when you step into a tub of water or a swimming pool? When an object pushes water, water pushes back with as much force as it can, and this is called as the buoyant force or the upthrust. If the water can push back as hard, the object floats, like in the case of a boat. But if the water is not able to push back as hard, then the object would sink. Look at this ball made of cork. Cork being a very light object, the buoyant force would be greater than the downward weight of the object, and therefore it would float. Similarly, a ball made of wood would also float because the buoyant force is slightly greater than its weight or downward force. Whereas a ball made up of iron would sink because its downward force or weight is greater than the buoyant force. A watermelon, whereas, would neither sink nor float but would remain just below the surface of the water. This is because the buoyant force and the weight of the watermelon is balanced perfectly in this case. You must have observed that whenever a body is immersed in water, some water is displaced or removed. Now, if we can calculate the amount of displaced water, the amount of displaced water would be equal to the buoyant force that is applied on that object by the water. If we remove this weight of displaced water from the weight of the object before we immerse it in the water, we would get the weight of the object when it is immersed in water, which would be lesser than its weight when it is outside the water. This is why objects feel lighter when they are placed in water. Now let's recap our learning. A push or pull acting on an object is called force. The effects of force are a change in state of rest or motion, a change in speed or direction in which an object is moving, a change in size of an object, or a change in shape of an object. Non-contact forces act even when two bodies are not in physical contact with each other. Examples are gravitational force, magnetic force, and electrostatic force. Contact forces act only when two bodies are in contact with each other, and we learnt about the frictional force, muscular force, elastic force, and buoyant force in some detail. Dear children, learn joyfully because what we learn with joy, we never forget. I hope you will be able to name all of these forces when you experience them next time. See you in the next video. Until then, bye bye and keep learning.